To keep the focus on the presentation, we ask that everyone keep their mics muted and webcams turned off. To be as efficient as possible, if you have any questions, we ask that you please type them into the chat box. It's the icon found at the top right of your screen. We will be answering them during the Q&A after the presentation. Lastly, anyone who does ask a question will get entered into a draw to win some prizes. Here with us today, we have Sean Lewis, VP of Sales and Marketing at Hoskins Scientific. And with FLIR, we have Jerry Beanie, Global Business Development Manager, and Manny Alced, District Sales Manager. I'll now hand things off to Sean to talk a little bit about Hoskins before FLIR takes over the presentation. Enjoy.
Thank you, Vanessa, and welcome everybody. On behalf of Hoskins, we certainly appreciate everyone on the call taking the time out today to attend our webinar. In addition to the work that people are aware of us, in terms of consulting and providing high-end scientific monitoring and testing equipment, Hoskins has also put a lot of effort into expanding our work around featuring thought leadership sessions and new product sessions, from our manufacturing partners. So today we are very pleased to welcome, the team from FLIR. And to get things started, I am pleased to turn things over to Jerry Beanie from FLIR. Welcome, Jerry.
Thank you, Sean. Hello, everyone. So as business at FLIR continues to move forward in this new normal that we're all living in, we've also really kind of continued to release new products, and I'm actually really excited to introduce them to you today during this presentation. I'm going to review some of the key features of the new camera systems and also provide just a few examples of some of the different applications where these cameras might be a perfect solution for providing some meaningful thermal data to you in your testing or experiments. When I'm finished with the formal slide presentation part, I'm going to hand it over to Manny Alced from FLIR, and then he's actually going to provide a live demonstration of the new FLIR Research Studio software. And as mentioned, after that, we're going to have a Q&A session to kind of wrap things up and answer any of the questions that people might have. So before I begin, I did just want to spend a few minutes talking about who FLIR Systems is as a company. As many of you may already know, FLIR's been in the infrared space since the early 1970s. It has really grown over the years through a series of mergers and acquisitions across really a wide range of different markets. This has allowed us to reach a revenue level of just below $2 million US in 2019. And while most people associate our company with defense systems, most of that revenue actually comes from our industrial technologies business. FLIR has become very diversified over the years, and a significant portion of the total revenue that FLIR generates comes from non-infrared systems such as CBR&E, intelligent transportation, people counting, automated intelligence, and so on. The FLIR R&D and science segment, and really the cameras that we're going to be discussing today, follow within the laboratory and R&D space, which is under the industrial technologies business unit. So as you can see here, FLIR as a company has a large global reach with active operations in more than 173 different countries. And although we are a US-based company, nearly 40% of our 4,000 employees are located in other regions. This means that FLIR likely has an office or a manufacturing site, maybe a development center, or at least a service operation nearby for quick and direct support, really regardless of where you call home. So, and really this global presence is reflected in the fact that nearly half of our revenue comes from regions outside of the US. Europe alone accounts for about 30% of our total annual revenue, which equates to just over 500 million worth of sales last year in 2019. And in addition to being a global company, FLIR is also extremely vertically integrated, especially when it comes to our R&D and scientific cameras. At the core sensor level, most of the cameras that we offer utilize a detector or IDCA, otherwise referred to as an integrated detector cooler assembly, that's designed and fabricated at a FLIR facility in our Goleta, California. Many of the lenses are also designed and assembled at FLIR plants in both the US and Sweden. And then all these components are then brought together to support cameras being engineered and built specifically for R&D and science applications by the FLIR teams in Niceville, Florida, as well as Täby, Sweden. This control of the supply chain really allows FLIR the ability to leverage technologies across a number of different business units, and also provides a lower cost basis for our cameras. So, as I mentioned, FLIR continues to move forward in this new normal under COVID, the COVID pandemic. But we continue to release new products. It hasn't really slowed us down. Earlier this year, FLIR launched a new line of uncooled microbolometer-based A-series thermal cameras into our automation and industrial safety markets. These flexible camera systems are the next evolution in compact and affordable fixed-mount thermal cameras from FLIR. The design of the new uncooled A-series cameras is really unique in that they utilize a base camera core that can be configured to fit almost any application need. But regardless of the final configuration, every one of the new A-series cameras has the same set of basic features. These cameras are small and they're relatively lightweight, especially when compared to some of the FLIR high-end cooled camera systems. They're also robust with a wide operating temperature range and standard sealed M-style connectors that allow the camera to have an IP54 rating right out of the box. But if you do need a higher IP rating, there's actually an accessory that can be purchased that improves that rating up to IP66. These cameras are also very easy to use and can be seamlessly integrated into existing systems. With standard gigabit Ethernet, that's both GigiVision and GeniCam compliant. It's power over Ethernet and has remote motorized focusing. You can completely control the camera and view data through a single cable connection. This can be done through the built-in web interface that's built into the cameras, or one of the different FLIR software programs, or even within your own software application if you desire. There's also a number of different options and extended features that really allow you to customize the camera to fit your needs. And with this ability to customize each camera, the new uncooled A-series are ideal for applications like process control, quality assurance, and condition monitoring. They're also great cameras for research and development applications as they work with FLIR's Research Studio software and have a number of the advanced features that researchers and engineers love. But I'm actually going to discuss that and those features in a few more slides. With these new uncooled A-series cameras, there are two main configurations to choose from. For custom software and user interface applications, the image streaming thermal cameras provide GigiVision and GeniCam compliance. If the application requires more of a quote-unquote smart camera that has onboard analysis, the smart sensor thermal cameras provide on-camera analytics as well as alarming that can be easily configured through a built-in web interface. And with the digital I/O, the camera can even be set up to output alarms to external devices. Additional features like Modbus TCP, RESTful API, and MQTT allow the smart sensor cameras to be used with industrial HMIs or even integrated into cloud-based solutions and web applications that really support Industry 4.0 and industrial IoT environments. It sounds like somebody might have put us on hold or is trying to get in, so I don't know, Sean or somebody, if you could go in and maybe mute that. For we don't have the beeping.
Everybody, Jerry, so I'm not sure what that is.
Yeah, okay. I just want, all right, good. All right. Maybe it's someone on our side, so that's all right.
It does sound like somebody's got us on hold, though, yeah.
Yeah, exactly. So that's all right. Well, I'll push through and try to ignore it, no problem. So, all right. So with these new uncooled A-series cameras, there's also a number of extended features available that really kind of further expand their capabilities. So whether you need to have a visible camera for real-time MSX imaging to clearly identify those objects, or you want to reduce cabling by using radiometric data streaming over Wi-Fi, you can actually add these features to any of the new A-series cameras as needed for your application. We even added an option for FLIR macro mode to these cameras to help you accurately measure temperatures on very small targets. So, and if anyone has used an uncooled FLIR camera for R&D in the last few years, you may actually be familiar with our existing A325 SC or the A655 SC cameras. These cameras have really been the bedrock of the uncooled science camera portfolio for a number of years. I think the A325 released almost 10 years ago. But with the development of the new A-series cameras for automation and industrial safety, we wanted to leverage the new cameras to provide really a unique value in the R&D and science space in those specific applications. So to do this, we actually created dedicated science kits that pull together a number of the accessories I mentioned previously and some of those options to provide a complete system that really meets the specific needs of R&D and science applications. The new A-series science kits are really ideal for applications where system flexibility and the ability to acquire meaningful data real quick are really important to you. As you'll see in the coming slides, the optics flexibility of the science cameras makes them ideal for electronics design and testing applications, while the intuitive Research Studio software that Manny is going to demo later is actually included in the kits, allows users with a variety of different backgrounds to acquire and analyze thermal data quicker than ever before. And with the advanced features and available IP ratings, these systems provide a critical tool in both indoor and outdoor life science studies. And when it comes to commercial R&D applications, the scalable nature of these new A-series cameras really allows them to be used during the kind of those initial research and development phases back in the lab. But those same cameras can actually be integrated into machine vision applications or condition monitoring applications out on the manufacturing floor at a later date. So they're very flexible systems. And as I mentioned before, all the A400, A700 cameras are built on the same platform. So every camera in the science kits actually will have the same basic features that I have listed here. So really, I'm sure you're asking, like, what are these new A-series science kits? Well, we've actually created 4 different kits built around the new A-series cameras. The standard kits include everything that you're going to need to get started, while the professional kits include everything already in those standard kits, plus a few unique options that provide even more value and system flexibility. These kits are based on the A400 and A700 advanced image streaming cameras that are offered for the automation and industrial safety, and they include a standard 24-degree lens. So we have both an A400 and an A700 standard science kit, as well as an A400 and A700 professional science kits. But I'm actually going to get into the specifics of each of the kits kind of in the following slides. But as for the cameras, the A700 is a 640 by 480 resolution camera with a 12 micron pixel size that provides over 300,000 total temperature measurement pixels. The A400, it has a 320 by 240 resolution detector with a 24 micron pixel size. This results in the cameras having the same overall field of view, or FOV, as the A700 when using the same lens, but that IFOV, or instantaneous field of view, or sometimes referred to as spot size, ends up being 2 times larger on the A400 than on the A700 cameras. All the cameras have gigabit Ethernet connections that are power over Ethernet, but we are actually using the RTSP data stream and not the GigiVision interface in all of these packages.
Jerry, just a quick question. Sorry, do you mind just muting for 1 second? And then I want to see if that beeping is coming from your side, or because we can't figure out where that ringtone is coming from. Just mute for 1 sec. Okay, it went away. Okay.
So it's on my side. Interesting. Yeah, because I didn't. Yeah. Because I just muted.
It's gone now.
Interesting.
Yeah, it's gone.
Okay. Weird, because I turned everything off on my computer, and I didn't even mute in go to meeting. I actually like muted on my headset, so that's bizarre. I've never had that before. So sorry, everybody. It might have been me. So. Yep. So. All right. So. As I mentioned, the standard science kits will include everything you need to get up and running quickly. This includes the camera, that 24-degree lens, and all those accessories, cables, connectors, and everything needed to connect the camera up and get it powered and connected to a PC. The cameras in these kits will also automatically come with the FLIR macro mode, and each kit includes a 1-year license of FLIR's new Research Studio software. If you're not familiar with it, I mentioned the macro mode. Macro mode actually automatically increases the distance between the camera's detector and the back of the lens. And what that does is that effectively reduces the minimum focus distance for a standard lens. Previously, this FLIR technology has really only been available for our handheld T-series cameras, but now it's now available in these fixed mount A-series cameras as well. And having macro mode as an included option really is a great feature when combined with the standard 24-degree lens that's included in the standard science kits. By itself, the 24-degree lens has a minimum focus distance of right about 150 millimeters. And at that distance, you'll get about a 212 micron per pixel spatial resolution with the A400 and 106 micron per pixel spatial resolution with the A700. But when you enable macro mode, the minimum focus distance actually drops to about 60 millimeters, and you can get a 101 micron per pixel spatial resolution with the A400 and a 50 micron per pixel spatial resolution with the A700 camera. This configuration provides better performance than pushing the wide-angle lenses inside their specified minimum working distance, and is more economical than having to purchase separate close-up lenses to be able to achieve those smaller spatial resolutions. And here are 2 quick example images of what can be achieved with FLIR macro mode. I know I'm speaking with a Canadian audience, so I'm sorry that it's not a loonie and instead it's a US quarter. But the top image was taken with the standard 24-degree lens at its minimum focus distance, while that bottom image was taken with the macro mode enabled. And though it may not look like, it might actually look like I simply just zoomed in digitally, the smaller spatial resolution and the overall field of view provided by macro mode really allows you to more easily see some additional features and crisper edges on that US quarter in the bottom image. So what about the professional science kits I mentioned? Well, the A400 and A700 professional science kits include everything that's already in those standard kits, like I mentioned, but we added actually a few unique items that will provide even more value. These include a visible camera and the ability to connect to the camera wirelessly. And on top of that, we actually added in a real close-up lens that provides a 48 micron IFOV on the A400 and a 24 micron IFOV on the A700 cameras. And for the cameras in the standard kit, the visible camera and Wi-Fi capabilities do exist within the cameras. They're simply not enabled. So if you happen to purchase a standard science kit, you can always choose to enable those features at a later date. However, we've actually priced the professional packages at a point where it's really more advantageous to purchase the Pro kit versus upgrading to these options separately at a later time. So with the visible camera enabled in the professional science kits, we'll not only be able to display the infrared image in Research Studio, but you also have the option to display a visible light or real-time MSX image. If you're not familiar with FLIR MSX that we have on our handheld cameras, also known, it's referred to, or MSX is short for multispectral dynamic imaging, it actually adds visible light detail to thermal images in real time, which gives greater clarity by really embedding edges and outline details onto the thermal image. So unlike image fusing, where you're kind of merging visible light and thermal imagery, MSX actually doesn't dilute the thermal image or decrease any thermal transparency. So, and with the Wi-Fi connectivity that's included with the professional science kits, we're actually finally able to cut the cord between the computer and the camera. So using a simple ad hoc network between the camera and your computer, you can directly connect to either the A400 or A700 camera, you know, and that could be a computer or maybe a tablet running the Research Studio software, and you can stream fully radiometric data into the software for analysis and recording. Or you can set a static IP address on the camera and connect it to a wireless gateway for access within your network if you want. Of course, I need to make sure everybody's aware, but the speed of the data streaming into Research Studio can be greatly dependent on the hardware and the capabilities of the different systems that you use. Obviously, if you go through wireless gateway or something like that, depending on what the bandwidth of that is, you can greatly reduce the data streaming. But a simple ad hoc network on a PC running a good Wi-Fi connection that you're relatively close to, you can get the full 30 hertz. You know, from the camera into the software wirelessly. So it's really a great feature. So, and as I mentioned, the A-Series professional kits also include a standalone close-up lens. This new lens provides a 48 micron per pixel spatial resolution when used with the A400, which is the 320 version camera, and a 24 micron per pixel spatial resolution with A700. Again, since the pixel resolution of the A400 is 1/4 of the A700, they'll both have a similar overall field of view when using the close-up lenses. So when you look at everything that I talked about that's included in the professional science kits, from the standard 24-degree lens to macro mode to the close-up lens, we're really providing you with a complete close-up inspection system in a single package. For the A400 Pro kit, you know, you can get a 212 micron per pixel spatial resolution with the standard 24-degree lens at its minimum focus distance. You turn on macro mode, you can get 101 micron per pixel spatial resolution, and you if you want to put on that close-up lens, then you can get the 48 micron per pixel spatial resolution. And when you move to the A700 Pro kit, all those spatial resolutions are divided by 2. You step down to 106 with the standard 24-degree lens, 50 micron with the macro mode, and 24 micron with the close-up lens. So this is really an awesome value when you look at just the optics flexibility, let alone the visible camera features and the ability to stream radiometric data over Wi-Fi. So here's a quick side-by-side comparison of the different fields of view that can be achieved with the A700 professional science kits, when you're using those 3 different optics options: the 24-degree lens at its minimum focus distance, macro mode, and then also using the separate close-up lens. You can really see, as you step from left to right, you can really see the increased detail in the quarter. You know, as you go from the 24-degree lens to macro mode to that close-up lens. So when you combine the lens flexibility of the professional science kits with the included Research Studio software, you are truly able to record and analyze thermal images in very unique ways. As I mentioned, with Research Studio, you can connect to, and Manny will show this later, to multiple live cameras at the same time. You can open up multiple recorded files while being connected to numerous cameras. You can even analyze data from all the cameras and files simultaneously within the same plot or in the same table, which really allows you to quickly compare data and thermal trends. As you can see in this screen capture capture from Research Studio, I was actually able to easily open different images I recorded using the A700 Professional Science Kit and compare the temperature value of the small IC on all the same, within that same statistics table in the bottom left panel. And if these were movies, I could actually plot the time versus temperature values for the IC all within that same graph. And Manny will talk about this later a little bit more, but you know, if you're not familiar with the Research Studio software, or want to try it out, I highly recommend that you download a 30-day trial version from the FLIR Customer Support Center website, which is simply flir.custhelp.com. So yet another camera. So back in February, FLIR actually released the next generation of cooled compact infrared cameras that are specifically designed for research and development and science applications. You know, the new 8580 cameras really built on the already successful line of cooled A-series camera products, and provide a crisp, high-definition thermal imagery, and really those accurate temperature measurement capabilities, as well as the optics flexibility required by most industrial, military, and manufacturing R&D applications. Again, with simple single cable connectivity into FLIR Research Studio software, you can really easily view, acquire, and share meaningful data faster than ever before. So what's new about the A8580 cameras? If you're familiar with any of the cool A-series cameras from FLIR, it might have that same kind of general look and feel as the legacy camera systems, but the A8580 cameras are actually completely redesigned and now use an updated electronics platform that's currently in our other FLIR cooled A-series cameras. This updated platform allows the new cameras to use the standard FLIR HDC lenses that are compatible with all our other cooled A-series and X-series infrared cameras. However, the biggest enhancement really is the increase in the overall HD resolution and the addition of an internal filter wheel. But actually, we didn't stop there. The new 8580 cameras are the first in a new line of cameras that are compatible with the new motor focus lenses that we're offering from the FLIR Performance Optics Group. So let's go ahead and dive into some of the details of this camera now. As I mentioned, we actually increased the overall pixel resolution of the new 8580 cameras as a step up from the 8200 or 8300 cameras that you might be familiar with. So we upgraded it to a 1280 by 1024 resolution detector, which that equates to a total of 1.31 million measurement pixels. This step up in resolution actually represents a greater than 25% increase in resolution over those previous generation FLIR A8000 camera systems. And as you can imagine, these megapixel detectors really provide a wonderfully clear and sharp thermal HD image. And unlike the previous models, we're actually now offering both mid-wave and long-wave variants of these new camera systems. The mid-wave cameras use the FLIR in-antimonide detectors that are offered in both the standard 3 to 5 micron spectral response, as well as a broadband 1.5 to 5 micron spectral response. These mid-wave detectors provide great thermal sensitivity with NEDTs of less than 30 millikelvin. For the long wave camera versions, we're actually using the strain layer superlattice detector material that has a spectral response of 7.5 to roughly 12 microns. This highly sensitive detector material really offers dramatically better uniformity and stability through cool down cycles when you compare it to more of the legacy long wave MCT cameras. Actually, in fact, the SLS operates much like mid-wave INSPI does. You simply need to cool the detector down to its normal operating temperature to get a clear infrared image. The uniformity corrections done in the lab work just as well out in the field, which means you're able to start testing quicker without the headaches of recreating non-uniformity corrections that you had to do previously on most of the MCT detector-based cameras. So the new FLIR 8580 cameras also include the addition of an internal 4-position warm filter wheel. So by using this method for filtering, there's really no longer a need to remove the lens to install a neutral density filter when you want to switch to a higher temperature calibration range. This allows you to easily and more quickly switch between all the camera's temperature ranges. And with the 4 slots in the filter wheel, the A8580 can actually be calibrated from room temperature all the way up to 3,000 degrees Celsius. And you can see in the short video clip on the bottom right how the internal filter wheel indexes the neutral density filter into the optical path. This happens actually automatically when you select the temperature range that requires the specific filter. But if you're actually performing your own calibrations, you can also manually control that indexing filters through the software interface. One item to note, however, is due to the compact design of the A8580, as you can kind of see there, the filters are actually installed in the wheel at the factory, and they can't be swapped out in the field like the FLIR X series cameras filters can. So the filters, again, need to be installed at the factory or by FLIR service at the same time any of the high temperature calibrations are performed on the camera. So it's a little bit different variation from our the X series camera models, just to be aware of. The new 8580 cameras will also support, like I mentioned, the new motor focus lenses we released along with these cameras. The standard 4-tab HDC lens mounts you find on the cooled A and X series cameras from FLIR have really been updated on the A8580 cameras to include electrical contacts similar to what we have on the FLIR handheld camera systems today. This allows the camera actually to automatically recognize the lens that's being installed on the camera, which ensures that the correct calibration files are being used. The last thing you want to do is use the incorrect calibration file and think you have accurate data when you don't. This also gives you the ability to remotely control the camera lens focus point and actually even initialize auto focusing through the camera control interface. The great thing about this new lens interface is that it actually still supports the standard manual focus 4-tab lenses. So if you're lucky enough to have a cooled camera system that uses the 4-tab lenses and you have those existing lenses, or you simply don't need motor focus lenses for your application, you can just use the standard manual focus lenses with the new 8580 cameras. So it's really flexible from an optics standpoint. So, as I mentioned in the previous slide, with the release of the 8580 cameras that support both that manual focus as well as the new motor focus lenses, we've also released a whole set of both mid-wave and long-wave motor focus lenses based on standard f2.5 lenses we currently offer from the FLIR Precision Optics Group. These lenses will operate similarly to the lenses on most digital SLR cameras, and they actually allow the user to switch between motorized and manual focusing by simply using a toggle switch that you can see on the side of the lens. The focus control of these new lenses is actually done through the camera control interface. As you can see in that small video clip again on the bottom right, you can actually open up the camera controller within the FLIR Research Studio software to access the lens control function. You can simply press the autofocus button, or you can control with minor steps the near and far focus of the lens. You know, basically just through those commands or a simple, software toggle. And if you're using the auto focus control, you can also go in and set the size and location of the region of interest used for the focusing. So you're not set with a specific region of interest in the center of the image. You can actually set that autofocus region that that basically uses thermal contrast to anywhere within the overall field of view, which makes it really flexible in case you have a target that isn't specifically in the center of the field of view, and maybe you want to focus up in, you know, something that's up in the corner, you know, down in the bottom of the image. These motor-focused lenses will provide a valuable option in applications really where the camera needs to be mounted in a remote location, or maybe where access is not easier and maybe not even permitted, like an engine test stand or something like that. We're also planning to expand the support of these new motor-focused lenses across you know, the different cameras, including the X series cameras, as new versions are released over the next year. Get a drink here. So when it comes to the frame rate, the FLIR X series cameras are the high performance option when you truly need like those really high speed thermal imaging. With the A8580, we focus more on providing an HD resolution camera system with a compact form factor and unique feature set. So on the 8580, the maximum frame rate at the full 1280 by 1024 resolution is 44 hertz or 44 frames a second over gigabit Ethernet. And that's actually the limitation of the gigabit Ethernet communication bus. But you can actually achieve 60 hertz or 60 frames a second using the coax express connection on the back of the camera. Yeah, and I mentioned that, yeah, this difference is the maximum frame rate is really due to those bandwidth limitations of gig-E at that full HD resolution of the camera. For higher frame rates, the 8580 can actually be sub-windowed down like any of our cooled camera systems, and that can be done in steps of 32 columns and 4 rows, all the way down to a sub-window as small as 32 by 4, which is pretty much really, really tiny. But since the 8580 camera is optimized for really those high definition thermal imaging, the maximum available frame rate at that minimum window size is just under 4,000 frames a second over both gigabit Ethernet and coax express. So, and although the 8580 is built on a completely new platform, it still offers the same flexibility of connections as the previous A8000 cameras. Both gigabit Ethernet and a single channel coax express connection are available for digital data and camera control, which give you the ability to use the type of connection that's most convenient to you. These interfaces both are actually GeniCam compliant, which allows the 8580 camera to directly interface with a number of third-party recording analysis programs like MATLAB or any other third-party GeniCam-based programs. And with the HD SDI video output and the typical FLIR cooled camera features and options like sync in, sync out, and a trigger input exposed with which is all exposed through an auxiliary breakout connector. The 8580 camera provides really provides the features and flexibility of higher end camera systems. And if you have an existing FLIR cooled A series camera in your lab or at your company, you'll really find the 8580 a seamless upgrade path to an HD resolution thermal camera. So as I mentioned previously, with the 8580 camera systems, both the mid-wave and long-wave versions are compatible with the existing 4-tab HDC manual focus lenses that are produced by FLIR Precision Optics Group. This means that every manual focus lens that can be used on the new 8580 camera can also be used across any of the recent FLIR cooled camera systems, which really helps to greatly reduce the cost if you happen to be lucky enough to have more than one FLIR cooled camera system. But the manual focus HDC lenses are offered in standard focal lengths from 17 millimeter all the way up to 200 millimeter. For both the mid-wave 3 to 5 range as well as the long-wave SLS band. We also have manual focus lenses for the broadband mid-wave camera, standard 25, 50, and 80 millimeter. All those lenses are also compatible with our extender rings to provide even more optics and field of view flexibility depending on what your application needs are for that. So The new 8580 cameras are also compatible with the existing HDC microscope lenses. There's a 1x lens available for both the standard mid-wave 3-to-5 camera and the long-wave SLS camera that provides a 12 micron per pixel space resolution. On the 8580, this gives you an overall field of view of 15.3 by like 12.2 millimeter at a working distance of 30 millimeters, so just slightly over 1 inch. This is really a great lens for making accurate temperature measurements on small surface mount components, or really anything that the size is small of like maybe down to like a human hair. But for the mid-wave camera, we actually offer a 3x microscope lens as well. And with this lens and camera combination, you'll get a 4 micron per pixel space resolution. And that gives you an overall field of view of just over 5 millimeter by roughly 4 millimeter with that full 1280 by 1024 resolution of the camera. That means that you'll have 1.3 million measurement pixels in that small little 5 millimeter by 4 millimeter area, which is amazing. And so this allows for really accurate measurements on bond wires of integrated circuits or other very small structures. And since the working distance of the 3x lens is still 30 centimeters, there's actually enough room between the lens and the article being tested to allow for probes or other devices to be used during the test. So it's not, it doesn't close you off because there's a significantly small working distance. So, and just a couple months ago, FLIR continued to really kind of expand that cooled A-series camera family when we launched the new A6780 mid-wave and long-wave camera systems. The new 6780 cameras are built on the existing 6750 cameras, if you're familiar with them, which all use our new, what we refer to as Saturn electronics platform, the engineering decided to use basically planets. But this means that the new cameras are offered in the same wavelength, the same F numbers, and the same core features as the current 6750 variant cameras, both mid-wave and long-wave. This means that the 6780 cameras provide the same key benefits as all of the 6700 camera systems offered from FLIR. And internally, we refer to these as the 5 S's. The first S is speed or high frame rates, as well as fast integration times, which allows you to never miss an important event. The second is thermal sensitivity, really without the need of any image processing. So you can image and measure the tiniest of temperature changes. The third S is spatial resolution, which you can see down to the micron level, so you can make accurate measurements on really small targets. The fourth is synchronization and triggering, so you can record the exact data you need when you need it. And really the last S of the 5 S's is spectral filtering. So you can see what you need or want to see, or maybe see what you don't want to see within your application. So we always look at this and refer to this as the 5 S's for the cool camera systems. So what's new about the 6780? I've talked about the 8580, and the A series, the science kits. These new cameras, like I mentioned, essentially look the same as the current 6700 and 6750 camera systems, with the exception of a slightly larger extended lens interface in the front of the camera. This modification was required to allow the new cameras to have room for an internal 3-position filter wheel, while also adding support for the new motor focus lenses that I mentioned previously. And of course, the new cameras are compatible with the software that Manny's going to be demoing here shortly, and the full line of mid-wave and long-wave lenses that I've mentioned. But let's just dive in real quick on some of the exact camera details here. So like the 8580 cameras, the 6780 will provide that internal warm filter wheel, so you no longer need to remove the lens to install an ND filter when you're going up to a higher temperature calibration ranges. You'll now be able to switch between the different ranges more easily. But unlike the 4-position filter wheel and the 8580 cameras, the new 6780 cameras only have a 3-position, in the filter wheel. And that's actually due to the smaller cross section of the 6700 camera platform. However, the 6780 can still be calibrated from room temperature all the way up to 3000 degrees C using neutral density filters, just like the 8580 camera. But like the 8580, those ND filters actually need to be installed in the filter wheel at the factory or by FLIR service, if an aftermarket temperature calibration is required for it. So just keep that in mind. For these cameras. And again, like the 8580, the 6780 cameras also support the new motor focus lenses that were released with the 8580. The standard 4-tab lenses mount that you find on the 6700 and 6750 cameras were simply replaced with the new lens mount that was, that includes those electrical contacts that were required to control the new lens through the software. So again, control for the lens for remote and autofocusing is done through the FLIR Research Studio, which really gives that ability to kind of step through the focus points or autofocus based on contrast within the region that you specified, as I mentioned previously. So, and with the as I mentioned with the 8580, both mid-wave and long-wave versions of the new 6780 cameras are compatible with the existing 4-tab HTC manual focus lenses that are produced by the FLIR Optics Group. This means that, again, if you're lucky enough to have multiple cooled FLIR cameras, you don't need to purchase separate lenses for each camera, as a single lens can be used across any of the recent FLIR cooled camera systems. And again, you mentioned this really helps to reduce cost and issues with optics compatibility if you have more than one FLIR cooled camera system. So, although this is not a new camera for FLIR, I did want to make everyone aware of the FLIR A6261 shortwave infrared camera or SWIR camera that we offered. These camera systems use an Indian gallium arsenide or InGaAs detector with a spectral sensitivity of 900 to 1700 nanometers or 0.9 to 1.7 micron. If you're not familiar, this is the region of the electromagnetic spectrum that falls between visible light and the thermal infrared band. And this region is really dominated by reflected light, but it still allows the use of conventional visible optics that can be made from glass. So this allows SWIR cameras to be used in a variety of unique applications. The 6261 is built on the same platform as the other A6000 cooled cameras like the 6700, 6780 that I just mentioned. And therefore, it shares many of the same capabilities. This includes the 640 by 512 resolution detector with a 15 micron pixel size and the ability to output data at up to 126 frames per second full resolution. The 6261 can also be sub-windowed like the other cooled cameras for even faster frame rates, and all data streaming and camera control is done using a single gigabit Ethernet connection. That gigabit Ethernet connection, like all of the cameras, is both GigiVision and GeniCam compliant, so it can be very easily integrated into third-party software programs. The InGaAs detector in these cameras is extremely linear over the entire dynamic range, and there's actually 3 selectable gain states that allow the cameras to perform, the camera performance to optimize to fit nearly any scene requirement, whether it's low light or high light. So here are just a few of the unique applications where a SWIR camera is the ideal solution.
Is it 566?
Is that Vanessa in the background? So anyway, all these applications are what we refer to as quote unquote imaging applications, which really means that we're not concerned about the underlying data. We simply want to use the image to make a decision. So the spectral sensitivity of the InGaAs detector makes these cameras ideal for imaging through fog.
Well, I'm glad I gave you a challenge.
I don't know if that's Vanessa. Can you mute her maybe?
I'm not sure who it is, actually. Everybody's muted, so.
This is someone who's dialed in on their phone. So if anybody's dialed in on their phone and is talking on the phone, can you please mute us? Thank you.
Yeah, that'd be awesome. Thank you. So like I was saying, the spectral sensitivity of the InGaAs detector makes these cameras ideal for like imaging through fog or marine haze, as well as the different types of paints and even blood, human blood, believe it or not. The cameras can also be used to inspect silicon billets for cracks and fissures in it, all the way down to silicon wafers either before or after they're doped. They can even be used to inspect solar cells to determine functionality and or troubleshoot areas of concern, either through driving the voltage on the solar cell or through electroluminescence testing. And because water absorbs infrared light at a wavelength range right about 1.4, 1.45 out to about 1.5 micron, the SWIR A6261 is really ideal for imaging and measuring a water's content as it dries. So, and real quick, this might get a little technical and we can follow up later, but you know, mid-wave and long-wave cameras really have been used for high temperature measurements for many years. But short-wave infrared cameras actually offer some advantages when you're measuring high temperatures because of their high sensitivity in that to high temperatures, as well as a better temperature measurement accuracy. So SWIR cameras like the 6261 have a very high sensitivity to high temperatures due to their wavelength sensitivity. The radiance curves for high temperature show that most of the energy is actually concentrated at shorter wavelengths. And if you actually look at the in-band radiance curves for various wavelengths, you can actually see that a SWIR camera receives more energy than a long-wave camera at high temperatures. For example, if you take a black body at 3,000 degrees Celsius, it will emit about 100 watts per square centimeter per steradian in the SWIR spectral band of 900 to 1700 nanometers, where it only emits about 1.5 watts per square centimeter per steradian out at the 7.5 to 14 micron band of your typical long wave cameras. So, and when undertaking temperature measurements with infrared cameras, you know, obviously every user should remember that obtaining accurate absolute temperature measurements really requires the material's emissivity to be correctly applied. And we don't need to get into the math here, but this expression describes the magnitude of temperature errors due to small emissivity errors, which is denoted by the delta epsilon symbol. This equation shows that the temperature measurement error rises linearly with the fractional error in the emissivity and with the sensor's wavelength, and that it rises with the square of the absolute temperature. But how does this actually work out in reality? How does it applicable, these two first things? Well, this chart might be a little hard depending on what your screen size is, and we can follow up. There's a white paper that we have that talks about this as well. But this chart actually shows that the temperature error resulting from a 1% emissivity change for different object temperatures from, I think it's like 500 degrees Celsius up to 3,000 degrees Celsius, and spread across the different spectral bands from the SWIR to the mid-wave to the long-wave infrared bands of your typical science-grade infrared cameras. So as you can see from the lines, the effective error due to the small emissivity change is actually significantly less in the near-infrared or SWIR band compared to the long wave region. So it's a valuable tool, not only because of its sensitivity at high temperatures, but because of, you know, the lower effect on, you know, measurement, or the lower measurement error due to any potential changes in emissivity during your experiment. So it's something to be considered. So it's really for this reason that the 6261 SWIR camera is really a great option for high temperature measurement. So especially when the material's emissivity is not known, or maybe it's changing. And since the detector in the 6261 has a very good linearity, it's actually ideal for radiometry and temperature measurement. So by using simple neutral density filters, we can actually calibrate the 6261 camera up to 1500 degrees Celsius as a standard, but under special calibration go all the way up to 3000 degrees Celsius. And switching between different warm filters or not using a filter at all simply requires, it doesn't have the internal filter wheel as in the other A-series cameras, so it actually requires the user to just remove the C-mount lens interface that's held in place by 4 simple screws. So it's pretty easy to switch between the neutral density filters on the camera. So, but have you seen, SWIR cameras can really provide very accurate temperature measurements while also reducing the sensitivity to emissivity variations. So this really makes them an ideal for high temperature measurement solutions, for welding applications or situations where you need to make measurements through glass, like looking at at the filament inside an incandescent light bulb. They're also great cameras to use in additive manufacturing applications where metallic compounds are being used, or maybe even in the production of different metals like steel and aluminum. So, and I mentioned it a few times throughout the different slides, and I promise you there's only a few slides remaining in my presentation before we have Manny here, but like to do a demonstration. But all the cameras I presented work seamlessly with FLIR's new Research Studio software. If you're not familiar with this is really the next generation of analysis software for R&D and science applications that provides a number of unique features and benefits. This includes the software's ability to run on Windows, Mac OS, and Linux, and it also supports 21 different languages natively, which gives you the ability to use FLIR cameras and take data in the environment you're most comfortable working in. In addition, the simplified user interface allows you to connect, record, and analyze data quicker than ever before without the need for extensive training. And we're actually not done developing Research Studio. Our software team is really continuing to add new features and capabilities into the software with a plan to release updates at least 2 times a year. And the great thing is that the code base for the Research Studio software allows these updates to be easily migrated across all the operating system platforms. So you're never going to miss out, regardless if you're working on Windows or a Linux platform. And again, like I mentioned before, if you haven't had a chance to use the Research Studio, I really encourage you to download a 30-day trial and try it out for yourself. We're personally really excited about this new program, and I'm sure you will be too as soon as you start using it. But real quickly here, the software provides a number of unique features that, like I mentioned before, really allow you to quickly and efficiently display, record, and analyze accurate thermal data. This includes the ability to connect to multiple cameras at the same time. You can even open multiple recorded files while being connected to numerous cameras, and you can analyze data from all those cameras and files simultaneously within the same plot or within the same table. This really allows you to quickly compare data and thermal trends. The Research Studio also supports customizable and savable workspaces. You're not only able to configure the workspace the way you want, you can save it and open it up against later. So when you save that workspace, it actually saves everything. It's not just that layout. This includes any of the files that you have open, any color palettes and scaling you have, any analysis modules that you have open. So everything is saved within that workspace. So it's really efficient for being able to utilize and do experiments for doing repetitive type experiments. And to help kind of keep track of everything and to make sure that you're actually creating a workable interface, Research Studio actually allows you to customize the layout and create unique names for each analysis module and tab that you open. I think Manny's going to show this in the demonstration here shortly. But we actually built a wizard into it to help make suggestions on the overall format, really in case you have any, you need help kind of laying things out on where you want to put everything. So, and of course, the thing that you'll notice first, when Manny opens it up, when you first use it too, is really the streamlined user interface. The text and small icons of the previous FLIR R&D software have been replaced with really large, meaningful icons that are really common across a number of other software programs. Most features also are only one layer deep, so you no longer need to use multiple button clicks to access the features you need. There's also a recent file bar at the bottom of the program that contains the files you recently opened as well as the last few files you viewed. And the great thing about this file bar is that it gives you an image of the file so you know the contents of the file without having to open it. But if you click on that file in the file bar, a dialog box actually comes up with a larger image as well as statistics about that file, basically the number of frames in the file, the duration, and the file size, as well as where it's located. And this is really a great feature for being able to select and open the correct files quickly. But if you need more screen space, you can actually minimize that file bar. And although it's really not a user interface, I always wanted to let you know that Research Studio can build plots without the need to play the entire file. Like most other features, this saves a lot of time during your analysis. There's also some improvements in the way you're able to thermally tune the image. Gone are the days of having to click through the menus to select new color palettes, only to kind of realize that it's not the correct one and you have to go through that whole process again. In Research Studio, you can simply hover the mouse over the different color palettes and the software will kind of preview the image with that palette. So once you have the one that truly optimizes the image you want, you simply click to apply it. And for level and span adjustments, you can set the upper and lower temperature limits or use the hand grab tool to grab the slider to adjust that level and span, really similar to how you could do it on the FLIR handheld camera today. So Research Studio also lets you to easily zoom in on images up to 1,000%. And zooming in and out is as easy as scrolling the wheel on your mouse. You can click some plus and minus icons. I think that Manny will show you. And if you're actually running the software on a device that has a touch screen or a touchpad, you can actually just use the pinch zoom feature as that device. So with that, I can pass this over to Manny, who will give a quick demonstration of the Research Studio software. So Manny, are you ready? I think I can stop sharing my screen and you can take control, I believe.
I am. Excellent. So thank you, Jerry, for that. That was really appreciated. Can everybody see my screen? Just to get a confirmation.
Yes, sir.
Excellent. Okay, so as Jerry mentioned, I already have the software loaded up. I don't have the camera connected with me right now. I only have actually one camera, which is an uncooled T840. It's a handheld camera that I'll be using, but I'll give you an overview of what we can do with the software. So first, one of the nice features, as I mentioned, as Jerry mentioned actually during the presentation, is the feature that you're able to connect to multiple cameras at the same time. And I think it is crucial for any software. When you have a camera, it's a good thing if you have a right camera, number one, but you have to have the right software to do the proper analysis. And I can tell you, I've been with FLIR for a long time, and I love Research Studio. I love the functionality and features of it, and the ability to especially have multiple sources running at the same time. So I'm just going to do the one connection right now, and you can actually see some of the cameras I've had connected in the past that it still remembers automatically. So if I do reconnect to those cameras, it would automatically have all the settings, everything else preloaded. So in this case, I just have the T840, so I'll connect that up. So as it's loading, you should see I'm going to be in live view very soon. Here I am. Hello, everybody. So I'm kind of standing sideways to the camera. So as Jerry mentioned, you have the live view of the camera. You have the zoom capability here, which you can do with your mouse wheel, or you can actually just do it with your plus or minus sign right here. You have all the options of the measurement tools. For those who are familiar with the FLIR cameras, we have this typical, we call it a box tool or area tool that finds the min, max, and average. You have the spot tool, the line profile, ellipse, and all kinds of things. You can hide the tools if you want. You can actually do different colors and emissivities per tool, instead of using a global option for parameters. So this is kind of some of the features that on the Research Studio. Now, one of the many features that I really like is the ability to run simultaneous data. So let's say this is my live view right now, and I want to load a recording. As Jerry mentioned, it gives you a wizard to show you where to place it. So in this case, I want to place it to the left of my screen view here. So we have a pre-recorded event from the past that's running. So I have my live view camera running and my pre-recorded event. Let's say I want to load up another one. And now, as Jerry mentioned before, when you click on it, it shows you the stats. So this was a recording that was done, it's 11 seconds with 25 megs. This is the file location. This is how many frames. So I'm going to load this one up. I'm going to put it below this one. So now if you look at this, I have two data sources running events that were pre-recorded with different measurement tools and a live view at the same time. Now imagine if I can have, what if I want to compare the recorded event data to current live view to see what the variations are? Well, now you can do that very easily. You click on the plot-based modules right here, and you choose, do you want to align the profile plot module or the temporal plot module? I'm going to use the temporal plot. It's going to ask you, what do you want to use? The image, the box tool. Let's use the box tool. We'll do the max. It's going to ask you, where would you like to place it? Above, below, or just replace the whole frame? I'm going to do below. So now what I'm doing is I'm plotting the box tool that you see right there. That's, as I move my hand over it, you see how it adjusts its scale temperature. Now, what if I want to have the same data included in my plotting right here? Very easy to do. Click on the window, the event that you want to plot from, choose the same thing. Let's say box 1, maximum. It's going to ask you, do you want to merge into the current module or do you want to place it? Do you want to replace it? So I'm going to merge it into. So now I know my data is a little off. I need to reset this data. Let me close that up again and do it one more time. All right, here we go. I'll plot this one. So now, unfortunately, yeah, the temperatures are different, but that's why you're seeing some variations. You would see, but you'd be able to see all the temperature data all together at the same time. I'll try this one and see what it looks like as well. Box 1, maximum. So I'm now actually merging. Now again, because the temperature sources are very different, that's why you're not getting the good view of the, but you would typically see all the variations together in one line profile plotting again. So that's, I love the feature is the fact that you can record, let's say you had 4 cameras. If you're lucky enough to have 4 different thermal cameras from FLIR, thank you very much for that, by the way. You'll be able to record a few of the same cameras at the same time. If you want to look at recorded events and compare them to a live event, you can do that as well. So you have all these options to run within the software. Let's say you want more space. You say, you know what, I need to have another tab window. Well, that's not a problem. You just add in a new tab, and now you have a new workspace. All these workspaces can be saved. So if you have more than one person working at the same with the camera systems for different applications, they can save them as a workspace. So everything that you've done with, you know, level of span, palette adjust, and all that will be all saved into your next recording event. I'm going to just go here. So one thing another feature that I love about is the palette selection. So the palettes, as Jerry mentioned before, we have all these choice of palettes. As you scroll over them, you see it automatically. So you don't actually have to click. It's kind of giving you a preview of what the palette. I like that because in the past where you have to click and see, now you can actually just wait and see as the event is running and looping back and forth. You see how the different palettes give you a lot of different views. We also have the filtering. This is for those who are familiar with Research IR. We always have the filtering capability. So if you wanted to record, you know, let's say our max continuous. Let's say you want to do tracking capability of an event. You want to see where the max pixels are, where they're going. Well, you can turn on the filter max continuous. And now you see every maximum pixel is being recorded. That's why you see the hands are kind of painting the screen right here. If I want, I can add more filters along here as well. If I wanted to do a filter capability on this one, for example, I wanted to see the little fine details that I might have missed, especially for circuitry. I can turn on frame subtraction. So let's do sliding subtraction. This shows me the relative to the previous 1 or up to 16 frames. I'm just going to do 3 frames. I'll do relative, meaning that it's continuously moving. And here it shows me the subtle differences that any changes might have occurred that I might have missed. I moved this when I was recording this. I moved the camera purposely just to create these effects for that. So these are the filters. If you're familiar with Research IR, you would have been already experienced with our filter capability, and you can add multiple layers of filtering on here. You're not limited to just one. It doesn't affect the original data. It just makes it easier to identify some of the issues. And again, you can zoom in to really see where the event might be. You can adjust your level and span by manual. I'm just clicking and holding right now, right here. You can do your data. If you want to see your info module for anything, you can choose it right here, for example. This is showing you all the information, the camera, date. So it's a very powerful software with a lot of great feature sets. I really enjoy it, and it's so easy to use. Honestly, anybody can learn how to use it. If you spend a bit of time, and you know, we do include with it the manual. If you click on the little question mark right here, it opens up the manual for you and gives you the options to read through. Hotkeys, everybody. I'm kind of the old DOS days. That shows I'm kind of, you know, giving myself an age here, but I liked hotkeys. I used to work with them a lot with Microsoft, with WordPerfect, if anybody remembers WordPerfect. So you can actually program hotkeys and you know, for start, stop recording, control all recording, all kinds of things you can do and adjust from here. So really some great features. I don't want to go through too much because I'm going to be losing you guys very soon. You've already spent enough time with us, but if you like more, please reach out to your local Hoskin representative, and I'll be happy. Somebody at FLIR would be myself or any of my colleagues, Travis or Braden. We'd be happy to help you out and you know, come up with some ideas and even let you try out some of the software. So that's it for my part.
Well, thank you, Jerry and Manny, for the great presentation. And thank you all for your questions. It looks like they've all been answered directly into the chat. We can now open the floor to anyone who wants to ask additional questions. One at a time, unmute yourself and ask away. Not all at the same time.
I guess we've answered a lot of questions already. Oh,
We certainly did.
Hi, thanks for the good presentation. I was wondering earlier in the presentation, Jerry said that it could see thermal image through glass. Is it possible to see through ceramic glass? Thanks.
Yeah, that's actually a great question. I remember there is, I'm trying to remember, I'd have to get back to you because I've encountered that application before, and there's actually if you look at the spectral transmission curve for ceramic, there's actually a point where it is somewhat transmissive, and I can't remember the exact wavelength off the top of my head, but that's something that we can, I can dust off some old notes and look at some spectral transmission curves for that. Obviously, it's going to be limited, if I remember right, it's limited by the thickness of the ceramic as well, but yeah, there's, I can look that up, and I think you also type the question into the chat box so we have your name, and we can follow up with you later. Unfortunately, it's been a few years, so I'm getting old. I can't remember exactly, but yeah, there is a specific band where ceramic is fairly transmissive, but I can't remember if it's in the SWIR, mid-wave, or long-wave band. But yeah, and if you know, with that, basically any of our cameras can be, I spoke a lot about neutral density filters for higher temperatures, but actually all of our cameras can also be, you know, spectrally filtered as well to help, you know, image through, you know, the ceramic at whatever wavelength that is where there's some transmissivity. So we'll just have to follow up. I can't remember off the top of my head. A great question. Thank you.
Thank you.
Jerry, there was a question in the chat that I didn't get a chance to answer about regard to LabVIEW. I don't believe we can run LabVIEW within the software, right?
No, you can't. So yeah, so basically the cameras, pretty much any of the cameras that we have that are GigaVision and GeniCam compliant can interface with LabVIEW through the GeniCam interface. Occasionally there's some hiccups with it because obviously the standard GennyCam interface, a visible camera has a lot more limited number of register entries than a cooled camera that has the ability to do sub-windowing and control a lot of different states on the camera. So I think National Instruments has cleaned this up, but previously what had happened within LabVIEW when you're using the GennyCam registry is when it would connect to a camera, it would force registry settings down to the camera based on whatever parameters were set within LabVIEW. And that could create some issues with the cooled camera, depending on exactly, because there's so many registries, it would take a long time to do it, and eventually LabVIEW would kind of fault out with it. And I think clean that up, that now they give you the ability to go in and say, on connection, I don't want to force all these registry settings down to the camera, so the connection's a lot cleaner. We actually have some articles on that on our customer support center website. Again, that's FLIR.custhelp.com, that talk about connecting the different cameras into LabVIEW. But long answer to say, yes, they do work with LabVIEW.
Okay, thank you.
And that's the beauty of having cameras that fit open industrial protocols like GigaVision and GennyCam, and on the uncooled A series like Modbus TCP, MQTT, REST API, stuff like that. Is that you're not beholding. But if you do want to do some unique programming, I didn't mention it. Any of our cameras also, we offer software developers kits that allow you to do your own interfacing and basically create your own application.
I also forgot to mention that you guys you can export any of the information to a CSV file easily. You can choose a selected region of interest or select the whole thing into a CSV from your current data as well. So that's a nice little feature. Is it possible to see electrical wiring inside? Okay, so I got two questions about seeing through surfaces. So in regard to, the question was, can you see rebar inside concrete and can you see electrical wiring inside walls? And in both cases, as long as there's a temporal difference that is emitted or radiated enough to the surface, you will see something. But obviously, without knowing the environment of the situation, you won't need necessarily. You can use it with the handheld. I've done heated in the parking lot, or oftentimes in a underground garage where they have a driveway going into the garage. They have heated lines or glycol lines. You can see those if they're hot enough. If they're not heated, there's no temperature difference, you will not see anything. Same thing with wiring. If there's heat in the wiring, you will see something through, but not necessarily. You don't see through surfaces. We only see what's on the surface as long as there's something radiating from whatever's behind it.
Yeah, correct. And it's kind of two different, we refer to as a passive thermography and active thermography. So passive is basically just looking at the material, the surface, and whatever thermal energy is emitting off the surface. So, and the camera is really detecting like thermal variations within that scene. In active thermography, you're actually imparting a thermal energy into that surface and then monitoring the diffusion of that thermal imagery or the thermal reflection over time. So there's actually kind of two different applications in active thermography. One's referred to as flash thermography, which is kind of time-based. So you look at that time-based thermal decay, and then the other one is lock-in, which is more of a frequency-based application where it's not as much of it's a series of pulses that you run FFTs on the data to pull out, different features. So there are active thermography techniques out there, where you can see subsurface defects. They're typically used in non-destructive testing type situations, and there's actually a number of companies that FLIR don't sell a turnkey, active thermography system. We're more of a hardware provider, and don't get into that as much. We basically leverage like really quality, high performance partners that provide, active thermography NDT systems out into the market.
That's right. And actually, somebody from Hoskin, Chris from Hoskin, mentioned that unfortunately TV misrepresents FLIR on all the time, as they show you can see through walls. I've seen cop shows where they're looking for hostages inside a building. They take a camera, and I've seen them use a T640, and they can see like there's 10 people behind 6 walls in the back of the warehouse. Unfortunately, that's not true. TV, Hollywood will give you misgivings about what technology can do. We don't see through things. We just see. There are certain techniques, as Jerry mentioned, can be used, but typically we don't see through anything. It's only whatever's on the surface. And then we got a question: how thick can it see thermal variations? So the question is, how thick can it see the thermal variations, be it the electrical wires or steel rebars and concrete? So that depends on the temperature difference. So as long as some of the cameras have a sensitivity of 50 millikelvins or 0.05 degrees. Some of them will have 20 millikelvins or 0.02. So as long as there's that little difference between the 2 pixels, you will see something. So if that makes sense in between. So that's what we usually say. It's more about, what you're asking about is the sensitivity of a camera, and that would, depending on, obviously, cooled cameras will be always much more sensitive than uncooled cameras for what they can see. All right, I think any Peter, Vanessa, if you have any other comments or questions, or I'm not sure how you're gonna. Did you want to do the draw? I guess we'll do the draw afterwards. We'll take the names down and go from there.
Exactly. I've taken all the names down, and we will contact the winner.
Excellent.
Yeah, thanks, Manny, and thanks, Jerry. That was great.
All right, folks.
Yeah, thank you, everyone, for your time today.
Thank you, everyone, for attending. Have a great day.
Thank you, everybody. Take care. Be safe.
All right.